Right, here's a Worcester RI, and another picture's a Glower Micron, and there's an Ideal Logic. So these boilers, they all suffer with firing on a small backfeed voltage when they're on a 3-port system. So in this video, I'm going to show you the difference that fitting a suppressor will make to that. So Ideal in particular would like to tell you to fit a new PCB, but yeah, you can fit this cheap, insignificant part, and it will repair it and make the boiler run the way it was meant to. So don't forget, if you want to support the channel as well, you can sign up to Patreon and help me out. I'd really appreciate it. Next thing I'm going to be filming, by the way, hopefully, is a little mini series on wiring to help get people up to speed. So at the end of this video, I'm going to explain why backfeed voltage happens, and basically it's a design flaw within 3-port valves. So we'll see you at the end. So just so you know, the boiler downstairs is turned off because it would run. The boiler would sit there running.
Okay. Everything's off. Room stats down. It's quite a high backfeed voltage, and this is on a new 3-port. 169 volts backfeed.
Okay, just so you know, the reason the pump and the boiler are not actually running now and getting everything hot is the customer has turned it off on the front of the boiler completely. That's the only way he could get his heating to be off.
So yeah, so basically everything's, well, when I say everything's off, let me explain how you get the highest backfeed voltage. What you do is you put the heating on by itself. Okay, hot water off, heating on. Move the valve, the 3-port, all the way over to heating only, and then lose demand. And the valve will stay in heating only mode. Okay, which is where this valve is now. It's in heating only, and that gives you the greatest backfeed voltage. So I'm going to fit a suppressor to this, and we'll see if that changes anything. I'm going to fit the suppressor up here across the switch live and the neutral. We'll see what that does. Okay, so as you can hear, the pump is still running. The pump overrun. The valve again is in, that's in heating only, that valve. And let's see what we have on here now. So that's the neutral there. Taking that right down to 28 volts. Okay. So the suppressor's fitted here
Between orange and neutral, and so now that boiler's not firing when it shouldn't be, which is what it was doing when I arrived.
as you can see, that's taken from 168 volts down to 28. So what a good job a little suppressor does.
So that £150 PCB can stay on the shelf in Plum Centre.
28 volts. Perfect.
Oh, come on, Ollie. Right, okay, I'm just finishing up the footage on the suppressor. I'm just going to draw a little diagram of a 3-port. I'm not going to show you the ins and outs of how the 3-port works. I'm just going to simply show you the internals in the situation where a suppressor is needed. Okay, so I'm going to draw the diagram as if the 3-port was in heating mode. Okay, it's fully in heating only. Then you lost demand because a room stat went down or a timer went off, at which point the valve would still be in heating only because the grey wire is what's holding it open. So I'm going to draw the diagram from that perspective. Alright, I'll get back to you in a sec. So this switch would have been in this position. Once the white wire powered over, that's the motor and that's the neutral, that's the blue. Okay, so the synchro motor is powered from two different sources. Okay, so but once it's once the white wire has that switch there would have been in that position, the white wire would have powered the motor over. Once it got to mid position, it would have then hit the micro switch and clicked this down, and then the grey, which would have had 240 on it as well because hot water's off, the grey would have then continued motoring the valve over all the way over to fully open for heating only. So that when you suddenly lose demand, you only lose demand on the white. Okay, you don't lose demand, you don't lose the power on the grey. So once demand's finished, you can forget all of this to a certain degree, okay? So you still have 240 here, and you have 240 here. The motor's constantly being told to work, but as well as the motor being told to work, you also have a backfeed voltage that can work its way through these resistors back onto this orange and fire your boiler. So your 240 volt runs around here back to your boiler, and that fires your boiler. So this is the situation you are in when you've had a heating only demand and then you lose the demand. You end up with this 240 here constantly trying to tell this motor to work, which in turn you get some backfeed voltage through these two resistors back into the orange wire. Okay, it can't go back down the white because this is a diode. This is basically a one-way valve for electrics. So a Honeywell, well, I shouldn't say Honeywell, any modern 3-port valve that's spring return uses this system, and this system, when it's in this situation, is constantly consuming power. It's constantly trying to turn this motor when there's no demand. So that's why the Sunvic motor power on power off valves were invented. They were more energy efficient than this, but because of the adoption of the other version by other manufacturers, the Sunvic version failed, even though in theory it's more efficient than the Honeywell version. Okay, so this is the situation. You've lost demand, so the white wire has no power on it now, but you still have 240 volts on the grey. So the 240 volt on the grey is constantly trying to make that motor run, and the neutral there is there, so the motor does try and run. But as well as that 240 going to the motor, you also get the backfeed voltage through this, which is a resistor, and this, which is a resistor, which gets into the orange. And the orange then sends that power, 80, 90 volts, or in some cases much higher, depending on it. Also depends on weird things like induced currents and loads of other weird stuff. So there could be some small voltage of say like 30 volts on this orange anyway, and then with all this it adds up to being more. But this is why you get backfeed voltage. Okay, and the suppressor, all it does is it takes that voltage there, and it I don't know if this is the right word. The suppressor sort of, I want to say, dissipates that down the neutral, which is in theory kind of what it does. It dissipates it down the neutral. This is in heating engineer terms. That's probably completely wrong in electronics terms, but that's the way I think of it, and that's what helps me understand this whole situation. So this is HeatingGeek CAD I'm going to write here.